All right, there we go. Advancing coreboot on Intel Xeon 6 based server platforms. So first, I'd like to thank everyone who collaborated on this, especially Shu Liu, who was the main person involved in this development effort upstream, Vincent Zimmer, Allison, of course, here, one of my colleagues, Lin Xingtang, who pulled all this together, made sure that everything went smoothly upstream, and, well, I'm now for presenting. So now, let's get into it first. What is even coreboot, and why should you care? So coreboot is a community-driven open source software project, which is a more lightweight alternative to UEFI, legacy BIOS or other boot firmwares, given that it is a little bit different in what it does. It just brings up the hardware and does nothing else, and then hands over to any payload that you want. Can be UEFI, can be anything else. And it is still compliant to anything that the industry cares about right now, be it measured boot, verified boot, TPM, CBNT on the Intel systems, and all the other security goodies out there. Another good thing why coreboot is important is that the code base itself is rather lean. It's all written in normal C, and it is very well audited, given that there are almost no CVEs, and the ones that show up can be handled quite quickly, while on UEFI systems it's oftentimes a bit more opaque. More things show up and people get confused which part is in their code. While coreboot already supports SBOM, so software bill of materials, you always know ahead of time what's in your server actually, what is running. It's auditable and there's no vendor lock-in, so coreboot can be written and provided by anyone who can read and write C. It supports a wide range of systems, and one of them which is really good at is x86 and especially Intel systems. Another thing is coreboot is more on a community-driven development project. So it's none of your proprietary corporate projects where you're forced to buy in binaries and releases from an IBV, but more on a broad community where there are hundreds or at some point thousands of different developers working on it. It's more similar to actually the Linux kernel itself, which is widely spread throughout the ecosystem and industry. There is, similar to how it's done in Linux, a separation of internal drivers, and it makes sure that it only has to do what it really needs to do. And given that the code base is so similar to Linux and how it's structured, even if you do not have any firmware or UEFI engineers, you can still get around working on coreboot, even if you have just normal Linux engineers, as they will feel right at home. So now I'll hand over to Allison for how Intel remains still committed to open source and coreboot in particular.
So one of the things that Intel has been working on for many years is really to collaborate in coreboot and bring in our different Xeon products. And so we started with the Xeon 4 about 4 years ago, and we're very excited to be here today to just talk about the latest integration and the advancements we did with our Xeon 6, which just launched a week ago, and how we worked with our partners in this open source environment to really make that successful. So as mentioned earlier, our interface, Intel's interface, is the firmware support package, the FSP. The FSP is actually broken into a couple different modules and phases that really eased architecturally in the integration in with coreboot. So we were able to line up where our FSP would line up to the phases that coreboot already had, and just to make a very easy integration process that we were trying to do earlier than we have in the past. There were quite a few silicon changes that came with our Xeon 6 product. And as a result of those changes, we did have to create a new folder, a Gen 6 folder within our Xeon support. The great part about that is that there's a lot of commonality and common libraries and common modules that exist in coreboot. And so in addition to the specifics that we were putting in for Xeon, we were actually also putting in features and capabilities and some great refactoring changes into those other modules that are shared, even backwards compatible with the other products in there. Another added benefit of this collaboration and our ongoing collaboration is that we're advancing the server support that exists in this open source community. And so in the previous generation, we had added in some RAS support, some NUMA support, and for the new CXL interfaces. And then with Xeon 6, we have even additional extended RAS support. We have our enlarged CBFS. We have additional CXL support as that spec progresses, additional NUMA and sub-NUMA clustering, and then we have quite a few accelerators in our chip that we were able to enable in the ecosystem, and then working on the RAS offload support that was mentioned by Nil earlier. And then maybe a cool part about this, I mentioned earlier, the trade-offs of trying to add new features and bring on new products, but then also do cleanup. And we were able to actually do some of that cleanup with this. So as we put these changes in, we actually cleaned up, took code out, so we weren't just adding. We simplified and strengthened a lot of those capabilities. And via those shared modules, a lot of the enhancements that we made with ACPI and SMBIOS and the NUMA refactoring did trickle down to the previous generations, so they're able to pick up that goodness as well.
All right, and I'll take over for the rest of this presentation. So now to reiterate on coreboot and what Allison already mentioned, coreboot is a thriving ecosystem. At some point, there have been over more than 1,000 people active working on it from all around the industry, be it AMD, be it Intel, be it smaller IBVs, larger IBVs, or even individuals themselves to just work on it and spread their knowledge. It's a lot more ISA on this project than on some more siloed, small proprietary solution. But upstreaming obviously has its challenges, given that it's such a large project that existed now for almost 25 years. Especially that collaboration with all the other partners in the industry is something that needs to be kept within a quality level. So no code can be rushed, even if there's something urgent. It can't be hacked together. It always needs to go through a very thorough review process. But after all, this keeps the code quality up, keeps bugs down, and also keeps the security level pretty high, given that no code can just be rushed in or approved by just a single entity. And one thing that I talked about earlier just a little bit, which I'll go into detail now, is the Linux boot approach. So completely different to what you're used to in UEFI is something that coreboot favors is let Linux do it. And this doesn't require that you're actually using Linux as your main operating system. You can also use FreeBSD or anything else that right now is supported there. And what this means is that Linux will actually be used in the boot firmware directly. And this way, we don't need to write driver code, which might be buggy, or we don't need to rewrite things that already exist in the field. We can simply just reuse Linux drivers in the firmware and let them initialize different peripherals later on. This also gives us the added benefit that everyone who can write a Linux application in normal user space can also now write bootloader firmware, something that makes it for other projects completely impossible. For example, for UEFI, it's written in some DOS-style C, and it's then forced to stay in C if you need to write new code, new business logic, or new applications for custom boot protocols. And it also requires a lot less code in general. While there are sometimes hundreds of Dixies and drivers in UEFI, where some people don't even know if they need it or not, they usually go by the principle of I'll include it anyways, because if I don't need it, it won't be called. But sometimes this can lead to security issues or bugs which stay unnoticed for quite a long time. While here we have SBOM, we support everything that Linux and coreboot support, and we simply strip everything down to just the kernel and your user space application that is then running on your Xeon servers. So now, call for action. Try out coreboot on a Xeon 6 platform. Right now, there are several out there. Xeon 6 is rather new, but it's already supported from day one, from the get-go. So if you have one of those in your data centers, feel free to try it out and let us know in the coreboot communities. And if you need any help with getting it running on your particular board, you can also give 9-Element Cybersecurity a call, and we're glad to help you out there. Any questions? You have to.
Just say you enable Xeon 6. If Xeon 7 come out, how much engineer resource you need to get it up?
So given that the Xeon 6 effort went quite smoothly, and in one of the previous slides we showed that there's a lot of code reuse happening, and especially now with the cleanup that has been done and the restructuring, I envision that Xeon 7 support won't take as much time as Xeon 6 did, because there went a lot of effort into Xeon 6 to make everything a bit more modular and reportable for future platforms. I can't tell for sure because I sadly cannot look into the future. If I could, I would probably play gambling now.
Estimate like 10 engineer, 100 engineer, you know.
Hard to say. I'd envision it will probably take a bit less than the Xeon 6 effort, and you can look upstream how much time took into this.
Effort you put into Xeon 6?
So Shuo and the others worked on this for, I think, well over a year, something like that.
A few people, like on the Intel side, we had a few people that worked for about a year making changes.
Basically, compare with Android, is when Google come out new Android version, right? So all the OEMs like putting a lot of resources to enable it.
Yeah, this one wasn't too resource intensive. I think part of it was just the learnings as well. It was the first time that we really made an effort jointly to enable something prior to our launch, so that you didn't have to wait so many weeks after launch to be able to use a capability in coreboot with Xeon. So we'll be able to leverage that moving forward for sure.
What is the typical time to go from, say, the Xeon 6 CRB reference to your customer's motherboard in coreboot, like getting it booting into an OS in that first go?
So to just get it booting, it also depends a little bit on how close the new board resembles the reference board, or if they simply just took the SoC and designed everything from scratch new. But usually most people stay close to reference designs, and that means that an initial bring up on this new board can happen within a week, and then the ins and outs need to be figured out over time. But it kind of depends a bit on how customized the hardware will be, and the closer it is to the reference, the easier and quicker it will be.
Really mean Tiano Core EDK2
Right.
type right.
So
because the reason I asked the question is that we actually have done Linux boot to put up a payload that presents UEFI, and we also did U-boot that supports UEFI as well. So I think there's a little bit difference in terms of, in my mind, UEFI doesn't necessarily mean Dixie, right? It's the Tiano Core that has the
yeah, right.
Dixie.
So nowadays, there's the UEFI ecosystem is a bit more broad than it used to be. So I agree on that. I should have specified a bit further that when I mean UEFI, I almost synonymously use it for Tiano Core EDK2. But yes, you're right. There's obviously the option to also launch U-boot's UEFI mode directly from coreboot. So you let coreboot initialize and then let U-boot just play the UEFI role here. Or as you said, implement application logic in Linux boot to actually provide the UEFI interfaces. There are plenty of options, and coreboot holds all doors open, basically.
Any other questions?
A general, somewhat naive question about KExec. Is there any focus that you would see happening in this community that might translate to making KExec an option on Intel?
I mean, KExec for the largest part is not really depending on the hardware itself. Right now, KExec works reasonably well when you jump from Linux to Linux or when you jump from Linux to a BSD-based system. There are efforts underway to also make KExec-based solution a bit more versatile than they are right now, especially when it comes to the KExec syscall and the different kernels, because that support from architecture to architecture is a bit spotty at times. but there's definitely future in KExec, and there are several of our customers which use it actively in the field, and it's more than just an experiment, and I definitely see future in KExec, to keep it short.
Thank you.
Thank you, Allison and Marvin.